Gas station looks like a brute force problem at first, but there is one greedy reset rule that collapses the whole thing into a single pass. Here is the exact problem. You have gas on each station, a travel cost to the next station, and you start with an empty tank. Your job is to return the one index that can complete the full circle, or -1 if no such start exists. The obvious idea is brute force. Try every station as the start and simulate the trip. But each simulation can almost reverse the entire array, so doing that from every index pushes you to O of n squared. The first real insight is global feasibility. If the total gas across the whole circle is smaller than the total cost, then no start can ever work. If total gas is at least total cost, then a valid start definitely exists. Now for the greedy proof. As you scan, keep a running tank. If the tank drops below 0 at station I, then every start inside that current segment also fails, so you can safely discard the whole segment and reset the candidate start to I+1. Let us trace the classic example. The net differences are -2, -2, -2, then +3 and +3. If we begin near the front, the running tank becomes negative before we can get far. Once the tank fails after station 2, we reset start to 3. From station 3, the extra gas from the last 2 stations is enough to wrap around and pay for the earlier deficits. That is why the answer becomes index 3. The implementation is small. Keep total, tank, and start. Add gas minus cost into both total and tank. If tank ever goes negative, move start to the next index and reset tank to 0. Here is the first half of the Python solution. We initialize total, tank, and start. Then we'd iterate once, computing the difference at every station and folding it into total and tank. And here is the greedy reset. If tank becomes negative, that whole segment is dead, so start moves to I+1 and tank goes back to 0. At the end, total decides whether any solution exists. Here is the full solution in one place. If you remember the global check and the reset rule, this code becomes easy to reconstruct in an interview. The memory trick is simple. If the segment fails, every start inside that segment also fails. That is exactly why the greedy reset works, and it gives you an O of n time, O of 1 space solution.